morning students, this is Junita Mukherjee once again in your class of physics for class 9th. Welcomes to you in the new session of 2021 and 2022. I welcome you for this physics class of class 9th. So we will today start the very first chapter of your physics, that is motion. And in this particular chapter we will learn about what is motion, and we will have exhibit different types of motion, and some exhibition of these graphs also will be there in this particular chapter, in this particular book. And through this we can exhibit that what is motion and what is the various types of motion related to this particular chapter. And let us start this chapter now. Motion is what? Motion is something that makes us move, okay? Or we are doing a to and fro motion. If we do sitting on a particular chair, we will move on a to and fro motion. This shows that we are moving in a particular direction, left to right or right to left or east to west or north to south. We are moving from in a chair, sitting in a chair itself. So generally we will have a motion, and that particular motion is what we call the movement of a body itself. So movement of a body is what we call motion. Clear? Now motion can be described in various ways, that is a zigzag motion, okay, a random motion, or a circulation motion, or a uniform motion, or a non-uniform motion, or you can say a motion in a straight line, okay. So motion in a straight line, first we will exhibit this one. So in the class 9 we will exhibit this one, what is motion in a straight line. So motion in a straight line can be taken as this. We are taking this particular path A, B, C and D. So the motion along this particular path, that is from A to B, B to C and C to D, is along the straight line itself. Clear? If the motion is just like this, in this manner, so it is a zigzag motion. So A to B, then D to C and C to D is a zigzag motion. Random motion means it can be like this, this, okay. This is also called the random motion, okay. Randomly any motion can happen. It's not a variant that came into exist in this particular thing. It can go like this, graph can go like this also, okay. It can go in any motion. That is what we call the random motion. Clear? So these are the various types of motion which we are exhibiting in a particular path, okay. So this is what we call basically this straight line, and we will add this particular value, that is AB plus BC plus AB plus BC plus CD is equal to AB. Clear? So this particular path is what we call the motion along a straight line. So this is how the motion along a straight line is being given to you. Now activities are being given in your meter scale and a long rope which is given in your basketball. Learn these two activities basically. Now motion along a straight line has been told to you. Some questions are being given here. An object can move through a distance. Can it give a zero displacement? If yes, support your answer with an example. Yes, it can have zero displacement. Why? Because if we are moving like this, okay, and just like this, and just like this again, and just like this again. Clear? So what will happen? A to B will have some distance, then B to A will have some distance, B to C will have some distance, then C to D will have some distance, and D to E will have some distance. So this minus this minus this minus this, what will be the value? This. Clear? Okay? So we will take all the values clearly and subtract it. What will the value? Displacement. This is what we call the displacement. Okay? So A to B, simply we can say that A to B and then B to A again. What is this? A to 0 to 10, or from 10 to 0 itself. What is it? Subtraction of both these things will be equal to 0 itself. So displacement can be 0. Okay? A farmer moves along the boundary of a a square field of a side of 10 meter in 40 seconds, what will be the magnitude of the displacement of the farmer at the end of the 2 minute 20 seconds from its initial position? What is the following? Which of the following is true for displacement? It cannot be 0. Its magnitude is greater than the displacement traveled by the object. So these two questions you just try to make it, solve it. If you are not able to solve, we can solve it out again in this particular session, in the next session itself. Okay. So these two questions you just solve it in your by your own. Okay. One I have told you. Uniform motion and non-uniform motion. The next is uniform and non-uniform motion. So non-uniform and uniform motion will be depending on the type of the values which we are taking in a graph or we are taking in a day-to-day life activity. Okay? So uniform motion. Uniform motion means this particular graph is here, just like this. Okay? This is the straight line. Okay? It is moving 5. Again this is 10. Again this is 15. Again this is 20. Just like this. This is again 5. This is 10. This is 15. This is 20. Okay, there is a uniformity, 5 divisions in each. So when it is the object, when it is moving with equal distance in equal interval of time, distance here and this time here. Okay, we can take any value. Okay, this is y, this is x, this is o, 0. Now this graph shows that uniform motion or a uniform motion can be defined as an object moves equal distance in equal interval of time. That is what we call the uniform motion. Clear? But in the non-uniform motion case, what will happen? It will move in different movements, just like this. Okay? So here it is 2, here it is 5, here it is 15, here it is 21, here it is 25, here it is 30, here it is 20, sorry, it is 21, it is here 21, okay, 2, 4, 6, 8, 10, 12, 14, 16 and so on. Okay? So it is not moving in a ratio. Are you able to find it out? 5 to 10. It is not 5. It is more than 5. Okay? This is 5. This is 15. This is 20. This is 25. This is 30. So where it is moving? 6. More to 6. 7. It is near about 7. Okay? This particular value is near about 15, 16, 17, 18 it is. 18. Near about 18 the value is. Okay? So it is when the object moves equal distance in unequal distance in equal interval of time, that is what we call the non-uniform motion. Unequal distances in equal interval of time. Equal interval of time means we have taken 2, 4, 6, just like this interval we have taken, right, and we have taken here unequal distances in this following. So distance will be here and time will be here. So it is moving with unequal distances in equal interval of time. So that is what we call the non-uniform motion itself. Then we have average speed. Average speed. What is the average speed? How we can calculate or how does the average speed comes up? We are talking about distance and time itself. So basically there will be a speed itself. Clear? Why there will be speed? Because we are talking about time and distance. So distance divided by time or distance divided by time is what we call speed itself. So we have the average speed value given by v is equal to s upon t. Where s is the distance, okay, and t is the time, and v is called the average speed. Average speed. Clear? I think I have made you clear, more clear. Now speed with direction. Speed with direction is what? Speed is something related to that of the distance, okay, and we will have this speed with direction means we will have this quantity with the a scalar quantity or it's a vector quantity. It will be a vector quantity. Why? Because speed with direction. When we have this magnitude of the speed equal with that of distance, or with distance with direction, then we will have this particular value as scalar quantity, as vector quantity itself. Because we know that the difference between scalar and a vector quantity is scalar quantity has magnitude and vector quantity has unit magnitude with direction. So we are moving with the average velocity. Initial velocity plus final velocity upon 2 is what we call the average velocity. That is VAV. VAV is equal to initial velocity and final velocity. So we can write initial and short, writing the short form, initial velocity plus final velocity upon 2 is what we call the VAV, that is speed with direction. Okay, or you can say average velocity. Average velocity, because velocity is the scalar quantity. Average velocity. Speed we know it. We have taken velocity. That's it. Average speed we have taken. Average velocity we have taken. But they have the different formulas. Clear? Its SI unit is not given, but the speed and the velocity have the same units. You know it. That is meter per second. Okay. And then we will move on to the next topic in the next session, that is rate of change of velocity, which we will continue in the next session. Till then, take care, and if you have any comment, please comment in the comment section. If you do not understand any particular topic, then also you will continue with that particular session.